All right, let's get to work actually assembling our leg mechanism. We have designed the two um, function generators, one for the hip, this one, and one for the knee, this one. So let's now assemble the cranks that are going to rotate it. Okay, first thing we'll do is introduce the angle that we're going to use to rotate it. All right, it'll be gamma 1. Okay, so there it is. And we're going to now introduce the crank here. Let's move this a little bit. Oops. So we can sort of see what's going on. Actually, let's see. I'm going to hide this. This is the coupler link. We're going to construct a coupler link for our system. So first thing, let's put in a parallel line. And that's where we're going to measure the gamma 1. And to do that, we'll introduce this circle and form this intersection. And then we're going to copy the angle gamma 1 here to form the crank. Gamma and underscore 1. Oops. Gamma. Come on. There it is. Underscore 1. Okay, and there is our crank. Make it green. And we might as well do the other one as well while we're at it. So let's put in the circle here. I'm going to move it out of the way just a little bit so we can, let's say, put it here. There's the intersection. So let's now measure and make sure that intersection's right. No, yeah, let's not do that. Yeah, we need we need it parallel here, here, and here. It's artificially parallel just because that one particular spot. So let's move it over here, and that's the intersection that we want. So here and here. It's awfully close. We'll zoom in so that we can now measure the angle. At the top from here to here, and that'll be gamma underscore 1. Underscore 1. All right, and here's our crank from here to here. Zoom out a little bit, and now you can see that as I rotate this crank, it'll take first position, second position, third position for input crank in coordination. So the two cranks are really one input. All right, now let's design our 4-bar linkage. First one we're going to do here is the hip. So here is the attachment of that coupler from here to here. Put it there, and then the coupler goes from this point to that point. I'm going to change the colors. I need to see that a little bit better. So this I'm going to make, there we go, a little bit brighter. All right, to distinguish it. Okay, so that is the length of the coupler, but it's going to be, I forgot to create the point at which it's going to be connected. So let's undo that. Let's put our point on here. So measure it from here to here. Get that intersection. All right, and now this angle, if I remember right, is kappa. Yes, kappa. All right, so now we'll measure that. From here to here, and there's kappa. And that gives our connection to the coupler that we need. Here to here. Here's our polygon, and we'll make it green. And this will be our connection to the coupler. All right, let's try that again. We'll measure from this point to this point, which gives us the length of the coupler. We'll attach it to the point on the moving crank, on the rotating input crank. So we see that it moves. We want the intersection from here to here, and that now gives us our coupler link. Over here, and the link itself is our follower. Make that red, and we can now see it. Let's go ahead and animate it so that we can see it rotate. There's our slider. We'll have it, it's going to be decreasing, and we'll turn the animation on. And there's our crank going around, moving our coupler back and forth. But we see that we actually have to attach the follower link to it. So let's stop it. We'll clean things up just a little bit and attach that. We'll attach that polygon. What don't we need? We can get rid of some of this. I don't think we need any of this. Any of these angles. Oh yeah, we need kappa and phi, or psi, kappa and psi. And then we also need gamma 1. Okay, so we've got rid of that. I think we can get rid of these circles. There we go. That can go. That can go. These can all go. That's random points down here. And that can go. Well, there's a circle we can get rid of. All right. Let's now attach. We have to design this polygon. So we have to attach it here. So what we want to do is we want to measure this angle. The angle from here to here and back up to here. And that is going to be our angle. Let's see what we got. Looks like theta 1 is the angle that we measured. And so we're going to measure that and copy that angle onto our output crank, onto output rocker. And that'll be theta 1. Theta underscore 1. And there it is. Okay, we can't quite see it, so let me move it around. Okay, let's get it right here. Draw the line along it from here to here. And now we're going to intersect it with the circle that defines the length of that crank, the length of that rocker, from here to here. So we intersect the line with that circle, and that defines our polygon of our output link. And this is important because this is the line that's going to define the eventual leg movement. All right, so let's rock that back and forth. You see it line up when it gets into the first position. There it is, first, second, and third position. Okay, that looks pretty good. Let's hide the circle and the line. So we're going to circle anymore. We can hide this line. All right, so that's the output crank for the first function generator. Now let's work on the input and output cranks for the second function generator. Okay, I'm just going to draw the circle in. Here it is. Get the intersection because I have to draw the link. All right, and now it's the angle psi, so let's copy that angle psi from here to here. Okay, and there it is. We'll draw. Okay, there's the segment. Make it green. And so this is our polygon. Make that green. All right, and this is our attachment of the coupler. And we can see that just by moving it back into place, making sure that it lines up. So it lines up here with the coupler like we expect. This is now going to be the attachment. I now have to construct the attachment to the output link. And we'll do that as we did before. We'll generate this circle. So here is the attachment to the output link. There's the circle. And here's the length of the coupler. So let's generate that. Okay, there's the length of the coupler. We'll put that where the coupler attaches to the crank. And here's the intersection. I'm going to hide the coupler just because it's too many lines, too many things going on. So we'll hide that. There's the intersection. That's the intersection we want. From here to here. And now we'll put the coupler in from our rotating crank. So it goes to there. We'll color it blue. And there it is. Okay. And then here is the output rocker. That'll be red. And we can now animate it. Okay, so you can see now that we've got two input cranks that are coordinated and two output rockers. Now we have the one output rocker that lines up like it's supposed to, but the output rocker for the knee we haven't added the polygon as yet. So let's go ahead and do that. And we do it the same way. Let's get it into a position where we can measure things. All right, so we'll measure this angle. So from here and back. Let's go see what that angle is. So that looks to me like lambda 1. Let's see if I'm right. Let's hide the others. Capital 1, was that? Okay. We need that capital. Oh, theta 1. Yeah, so we can hide that. So I need lambda 1. I'm pretty sure that's it. Looks like 5.89 degrees. Okay, so that's what we're going to copy onto our output link here. So we're from here to here, and we're going to copy lambda underscore 1. Okay, introduce the line from here to here, and introduce the circle from here to here, which is the length of the upper leg. Okay, we'll calculate this intersection right here. And now here's our polygon. And that's going to be red as our output link. Now let's move it carefully, make sure things line up properly. So it lines up with the first position like it should, and then goes to the second position, and it's lined up over here, so that looks good. And then in the third position right here, it should be lined up, and there it is. So they're all lined up. Let's get rid of these circles, and we can now animate the movement. That's right, I'll get rid of that line as well. All right, so this is the way the two function generators work together to drive the hip joint and the knee joint. All we have to do now is add the parallelogram that connects it to the foot. So let's do that right now. So I have a straight point here. I can delete that. Okay, let me just things here a little bit. All right, so where is the parallelogram? Well, it's here. So I'm going to draw a parallel line through this point. It's parallel to this portion of the rocker, and then just move things a little bit. So this line is parallel to this line. Then I want to, the second line is going to be parallel to this one. So select this through this point, parallel to this line. And that intersection now is our foot. So let's intersect those two. That gives us a point. Let's go ahead and look at the trajectory of that point. So I'll select locus, select that point. That point moves in response to the coupler link, and there we have it. That's our trajectory. That's our foot trajectory. And it looks okay. It's not perfect. We can move things around a little bit. Let's move the points. Maybe if we move the points a little bit close. Oops. Maybe if we move the points a little bit closer, it would make a difference. So you see everything adjusts as we vary the points. But maybe we're fine here. Maybe I don't need to be too worried about it. I guess I can adjust this point slightly, I believe, by varying the, whoops, that's the wrong direction. The other direction seems to help. So I can move this around a little bit, move those points. Actually, quite a number of things can be adjusted. And let's just leave it at that. Okay, so there is, we'll settle for that for our design of our foot trajectory. Let's complete the device now. So we have a segment that goes from here to here, and we'll color that magenta, that's the lower leg, and then we have a segment that goes from here. Whoops. Segment that goes from here to here. Oops, highlight segment. Okay. Segment that goes from here to here, and make that cyan. Make this segment magenta. Okay, and there is our leg mechanism. Clean things up just a little. Get rid of this line. Hide that line, hide that line, hide this point. Now, it's you can see that the flat portion of our step, this is the portion of the curve that we want against the ground. So the foot comes around, contacts the ground, and then moves generally horizontal across. What happens if I move this point out a little bit? It doesn't seem to help that much. Move it in, move it up. Oh, that looks interesting. All right, so now we can adjust the dimensions of the linkage quite a bit. So we can actually put the one crank right on top of the other crank. So we really just use one link, one input crank. Actually, let me put it down like this. So we'll have a curve that looks like this. Whoops, that's not working. We don't want it to disappear. That's a sign that the linkage is flawed in some way. So we'll try it down here. No. The designs were okay. Now, I've moved things around. Well, let me just, before I explore too many things and get pulled away, let's just go ahead and use the fact that this is flat along here to generate a translating link. I'm going to move this point A back a little bit, see if we can get it on the curve. That sort of helped, except I don't want those curves that far away. All right. Let's see if I can recover. Doesn't look so bad. All right, so we can do quite a bit to this mechanism in order to use the construction to explore solutions. This doesn't look as good as I would like. Let's see if I can move this back down. Get a little bit more practical design. I think I'm making things worse. It's getting better. Really get crazy. Let's go ahead and change the lengths of some of these links. There we go. I think you get the idea that we can use this design technique to sort of explore leg mechanisms of different types. Well, this one looks interesting. See if I can put this back on top. Let's move these around a little. That one seems interesting. Well, you sort of get the idea that we can do quite a bit in terms of adjusting the various parameters to get various coupler curves, foot trajectories. Still would like to have it a little flatter. I'm not quite sure what needs to be done to do that. I guess we'll just have to explore. I guess I can settle for that for now. Anyway, in order to complete the leg mechanism, you need a because the contact with the ground is here. I think I could adjust this. I think I can pull that up a little bit. I guess not. Ooh, it starts to break away. Over here, it starts to break away. All right, well, what you do is you simply duplicate the parallelogram linkage over here, and you can create a translating link that will move the foot trajectory anywhere you want in the plane so that you can put it down towards the ground. I'm not going to take the time to show you that right now, but I can show you an example. So let me bring that up right now. I think I have it. I think this shows it. Say, so this is an example. You simply take the parallelogram linkage that you just designed over here, and you reproduce it here. Now, I had a particularly nice curve here. I'm not sure how I got that. But what you can see is that once you get the curve you want, you can now add a parallel linkage. You can put it wherever you want. And then that causes this link to translate. And because it translates, you can choose any point on the link to connect it with the ground. And that's at least this example of a design of a leg mechanism. If the flat part of the curve is facing upwards, then we simply use a skew pantograph to pull it down towards the bottom. So we can handle whatever direction the flat part of the curve is facing. We can turn it into a leg mechanism. Anyway, thank you very much.